children. So this video is on chapter 2, atmosphere, for class 7 geography. So this is a continuation of the structure of the atmosphere. So today we are going to study about mesosphere. Last time we studied about stratosphere. So today we are going to study about mesosphere. So what is mesosphere? So resting above the stratosphere at a height of 50 to 80 kilometers, you find mesosphere. Mesosphere, meso, the word meso means middle. It's the middle layer. It is called the middle layer, okay? Now, the first point that I've jot on the blackboard is this is the coldest atmospheric layer and has temperature which is dripping from minus 90 degrees Celsius to minus 110 degrees Celsius. Just now only I told you it is the coldest layer. So the temperature here basically decreases with height throughout this layer. So whenever we are talking about temperature, so I'll make a graph here, okay? I'll make a graph here and I'll write altitude here. Okay, with the increase in altitude, okay, the temperature basically decreases with height. When the altitude increases, temperature decreases. So whenever I am talking about the decrease in temperature, it is shown by this graph. It is shown by this graph. Are you understanding? So this decrease in temperature basically, okay, is from 70 kilometers to 85 kilometers. From 70 kilometers to 85 kilometers, you find the decrease in temperature, okay? And this decrease you find throughout this layer. You do not find any concentration of ozone gas. You don't find any gases of ozone in this layer. So you don't find any ozone molecules in this layer. This means, okay, this layer is of vital importance because as meteors, okay, slows down and burns up due to friction and frictional heat, F-R-I-C-T-I-O-N-A-L, frictional heat, okay, when they enter mesosphere, M-E-S-O-S, mesosphere. Now you can read on the blackboard also. So meteor slows down and burns up due to friction and frictional heat when they enter mesosphere. What is friction? Now whenever you are rubbing your hand, this causes friction. Isn't that so? Mesosphere is fairly a dense layer. Now whenever we are talking about mesosphere, it is a dense layer. Okay? It is a dense layer. This mesosphere is a dense layer. Okay? So as meteoroids or meteors or asteroids enter mesosphere, there is a lot of friction between air molecules and the object. The object is meteors. The object is meteor, okay? And the air which is surrounding the, okay, mesosphere basically comes in contact with this object and causes friction. Therefore, this meteors burns up from this layer, okay? So as the meteor or the stone basically comes from outer space, basically enters mesosphere, it starts burning because it comes in contact with the air molecules. So another point that you have to understand is the upper layer of this mesosphere, okay, is called mesopause. So the upper limit of the mesosphere is called mesopause and the lower limit is called the stratopause. So the lower limit is called the stratopause. But I have written stratosphere here because for you to understand that after stratosphere comes mesosphere. But this layer, the lower limit is called S-T-R-A-T-O, stratopause. Okay. Now we are going to another layer, okay, that is called the thermosphere, okay. Now we are doing about thermosphere. Now I want to make thermosphere with this. Okay. Now I am drawing here. This is called Mesosphere. This is called THERMO, thermosphere. This starts from 80 to 450 kilometers. Okay. So the fourth layer that comes after mesosphere is thermosphere, which basically starts from 80 kilometers to 450 kilometers from the surface of the earth. Thermo, the word thermo, THERMO, thermo means, okay, thermo means heat. Therefore, it is the warmest or the hottest layer. So it is the warmest or hottest, HOTTEST, hottest layer. The temperature increases with height in this layer because it is the hottest layer. Therefore, you find, okay, as the altitude increases, so I am writing A for altitude, okay, AL for altitude. As the altitude increases, the temperature also increases. The temperature also increases because this layer is the warmest layer. So the graph which points this side is the rise in temperature with the rise in altitude or height. So the temperature increases with height or altitude, and it may reach as high as 1400 degrees Celsius. So the temperature of this layer is 1400 degrees Celsius. Okay, as this layer absorbs, okay, various type of solar radiation. And why does the temperature rises in this area or in this layer, not in the mesosphere, not in the troposphere, or not in the stratosphere? Because you find various type of solar radiation in this layer. For example, okay, ionization of molecules happens in this layer, okay, due to ultraviolet rays which are absorbed by this layer. Okay, you find X-rays also in this layer. So different kinds of solar radiation are found in this layer. X-rays are found as well as gamma rays are found in this layer. Therefore, you find this layer, okay, layer of very warm. Okay, so in this layer you find ionization of molecules. Okay, we are talking about molecules, okay, and atoms. Okay, so you find various kind of molecules and atoms. So I have made plus and minus sign here. Okay, it's a what we call concentration of molecules and atoms that you find in this, okay, layer. So what is ions here? Ions are found in this layer. Ions are found in this layer. Okay, this results in the breaking up of molecules of atmospheric gases into electrical charged particles known as ions. So what are ions? They are electrically charged particles. ELECTRICAL, electrically charged particles. Charged particles are called ions. And these ions are the reason why we have radio transmission. Okay, so radio transmission is basically, okay, basically due to these ions present in this thermosphere. So these ions reflect radio waves back to the earth and enable radio broadcasts and wireless communication. This layer is also known as ionosphere because you find lot of, okay, ions in this layer. Therefore, we call it ionosphere also. This layer, thermosphere, is also called ionosphere. Okay, but as you know, thermosphere is a bit weird. Okay, as it is not dense, as the air molecules are spread far apart. and it is spread so far apart that the humans, when they basically enter this thermosphere, do not feel hot. Due to what? Due to heat, the air molecules spread far apart. In this layer, temperature decreases with increase in elevation until a low point of minus 100 degrees Celsius is reached. So in this layer, temperature also decreases, okay, and temperature also increases. This is the reason why humans feel less hot in this, okay, thermosphere. Now in this layer, okay, you find, okay, oxygen atoms are also found in this layer, as well as, okay, you find a nitrogen, but nitrogen is found in less quantity, or it's a rarefied gas, okay. And this ionosphere or the thermosphere is a layer of charged particles called ions, okay, and light gases like oxygen, nitrogen, helium, etc., which causes a natural light, okay, displayed in the Earth's sky during night, okay, known as aurora, okay. Now this, because of this thermosphere, we find, okay, lights, okay, displayed in the North Pole and the South Pole. Okay, because of ions and because of light gases present in the thermosphere, we find, okay, different kinds of lights are displayed in the sky in the North Pole and in the South Pole. They are called aurora, A-U-R-O-R-A, aurora, okay, aurora, which is seen in the North Pole, which is also seen in the South Pole. In the North Pole, it is called A-U-R-O-R-A, aurora, okay, B-O-R-E-A-L-I-S, Borealis, okay, Norway. It is found in Norway. Okay, this is called the northern light. This is called the northern light, whereas aurora australis is also found in the South Pole. Okay, this is called the southern light. Australis. Okay, spelling is Australis. A-S-T-R-A-L-I-S, Australis. So these lights are caused by what? These lights are caused by ions, light gases that is found in the thermosphere, as well as solar radiation. So this is the reason why we find northern lights and southern lights in the, okay, polar regions. This is due to the ions present in this layer, which basically heats up this layer also. Okay. Now the last layer that basically I want to discuss is exosphere. Okay. Let me finish it. Okay. Now I have drawn here, okay, only thermosphere. And I'm writing here only 450 kilometers to OUTER, outer space. Now I'm writing here EXOS, exosphere. Now note on the blackboard that I have not marked any boundary there. Okay, I have not marked any boundary there. As discussed earlier, exosphere is the uppermost layer of the atmosphere. So this is the fifth layer, okay, which forms the outermost boundary of our atmosphere. So in simple words, it is called the topmost layer. Which forms the uppermost layer of the atmosphere as well as the outermost. It is also called the OUTER, outermost boundary of our atmosphere. It is thousands of kilometers thick. Okay. and merges into interplanetary space. It is thousands of kilometers thick. It starts from 50 kilometers and basically joins with the outer space. This outer space is also called interplanetary, Planetary, planetary space. Are you getting my point? And here in the diagram also, in the blackboard also, I have not drawn any boundary or line in order to make you understand where exosphere stops and space begins. So I have not marked any boundary where exosphere stops and space begins. There is no limit. Nobody is able to measure the distance. It is thousands of kilometers thick, and we actually don't know. As you travel in the exosphere, there are fewer and fewer molecules with an increase in altitude. As you go away from the Earth and basically pass through exosphere, you find fewer and fewer molecules of air. Molecules of air. With an increase in height. They become more and more spaced apart until you are basically in a vacuum, because as you go far away from the Earth, you find less molecules. They are spaced far apart from each other unless you enter a vacuum. Okay, vacuum is outer space. Now whenever we are talking about VACCUM, vacuum means outer space. It means outer space. Exosphere is composed of very light gases. We find traces of very light gases like hydrogen. You find that. You find helium there. You find oxygen also there, but in less quantity. But in very less quantity, you find less hydrogen, less helium, less oxygen, etc. The air here is extremely thin because you find fewer and fewer molecules here. So you find the air is thin and rarefied, and that makes the atmospheric pressure the lowest in this layer. So you find less pressure here because the air is less, so you find less pressure here, so you find less temperature here. The temperature is very high. The temperature is very high here. Temperature is very high here. It is basically 300 degrees Celsius. So here, with the increase in altitude, you find increase in temperature also. With this, I have finished the structure of the atmosphere. I'll be sending you like the significance of the atmosphere by WhatsApp. Thank you for listening.